Hey, this is Charlie Thompson, and this is a quick video about San Diego and physical geography. So over the summer, I went down to visit my daughter in San Diego, where she just graduated from UC San Diego, and it's one of my favorite flights. The flight from Sacramento to Los Angeles or Sacramento to San Diego, it's just an amazing flight because you fly, you can see the Sierras, you can see Yosemite, you can see active wildfires. And as a geographer, I always want a window seat because the views out the window are amazing and the things you can see are fantastic. So here we've got San Diego. So we've got this broad, flat area. People like to build cities in big, broad, flat areas. Los Angeles is a good example of it. So let's zoom in a little bit. And one of the things that's really, really, really obvious about San Diego is the canyons. The effect of the canyons, and let's zoom in a little bit more, is these canyons. Canyons play an enormous role in shaping the geography of San Diego. And as I was driving around, I realized to what a really large extent, for example, you can see this road passing through, not the canyons, passing through the flat spots. Some of the times the roads will follow, like here's one following this canyon, here's another road following the canyon, but the canyons seem to have a really outsized role in shaping, like I said, the geography, the settlement patterns, where they put the streets and the houses and all that good stuff. And I couldn't help but notice that the tops of the area in between the valleys, they were flat. And I wondered, well, are the houses there because it's flat, or did they flatten it and then put the houses? And so I decided to do a little GIS work. And so now we've got an elevation scheme going on. And if we do it the other way, so you can see this is the lowest area. This is the highest. Well, actually, that's the highest. So I did a color scheme going from purple into blue, into green, into yellow. Yellow is the highest elevations, and this purple are the lowest elevations. And once I started to look at things this way, using a GIS system, I realized that there appear to be three different landforms, three different types of landforms. And so this is La Jolla. Let me zoom in a bit. There's Torrey Pines. This is UC San Diego. In here, there's the airport. There's Mission Bay. So if I tilt again, you can hopefully see that this area is flat. This area is flat, but at a different elevation than the purple area. The blue area is flat, the purple area is flat, and then some of the yellow and the green areas are completely not flat. So there you can see it's flat. Here you can see they're not flat. They're relatively steep ridges with valleys in between them. So what I did was I created a layer to show what the sea level would have been if it was about 150 feet higher, which it has been in the past. Or I'm sorry, 150 meters higher. So it occurred to me that what we're looking at is the results of two different stages in the geomorphological development of La Jolla as a result of these two different periods with two different sea levels. So sea levels go up and down. Sometimes it's because the land itself is getting lifted up by plate tectonics. Other times it has to do with climate change. When the planet's warmer, there's less ice on the land, so there's more water in the ocean, so sea levels are higher. On the other hand, when it's colder on the land, there's more ice, and so sea levels drop. So I thought this was interesting. Here's the first layer, and then you can see that you've got these valleys that would have had streams running in them at different points, but then we've got the flat areas, and these are the flat areas that I was wondering about, like where UC San Diego is. And indeed, if we turn on the higher sea level, you can see that it starts the geography, the physical geography of San Diego, or at least La Jolla, starts to make a little bit more sense with these rugged ridge lines at the higher elevations. So they've never been underwater, and the importance of them being underwater is they're exposed to wave action, and as the result of this wave action, as that's upside down, that's no good. As a result of this wave action, you can see everything's very flat. In fact, the things that are sticking up are the buildings. If I turn off the 3D buildings so we just look at the landscape, you can see how really flattened out it was at that roughly 310 meter level. So now we've got the 150 meter level, just the lower water. And you can see that none of this would have been affected at higher sea level periods of higher sea level, that the wave action is what flattened out the landscape, that without that wave action, and let me turn the buildings back on, these flat areas that allowed the creation of the city, these urban areas in La Jolla, without that higher sea level flattening out these areas, the geography of San Diego would be completely different. So that's it for this. I hope you enjoyed this quick video about the physical geography of La Jolla as a function of sea level rise.